Okay, so so then on Thursday we're going to have quiz 2. Quiz or exam. This is going to be over software. And it's going to be over internet. It's only going to be over the part of the internet that I cover today. Okay? That's all it's going to be over. Okay. Oh, I'm sorry. Also PowerPoint. I might ask some questions about that, particularly about animation. And so that's what the cut is going to cover. So we look at the revised agenda, okay? And here we are today. What we've covered since the last test are software, presentation, and I only did a little bit of that because you know it already. I did the animation thing and internet, okay? And on the internet, it's only really what I'm going to cover today. So these are found in your textbook, and software is chapter CO3. Internet is CO4. Presentation software is SO8. So if you want to go and look at that chapter, that basically covers PowerPoint. So how to study for the test? Well, you should look at the PowerPoint presentation CO3, and you should look at the PowerPoint presentation 4 and SO8, okay? On the textbook, you should read chapter CO3 and CO4, at least the part that I get through today, and SO8, okay? SO8 has a lot of videos about training videos on PowerPoint, if you wish to watch that. Now in the textbook, should level this up here. So now remember how to get to the textbook is you go to E textbook here. So you can click on concepts, and it expands concepts. Let's say you look at software. This gets over to software, okay? And you can read, this is the beginning of the chapter on software. Notice here there's a self quiz, okay? You go to the next page, okay? And you can read that page. There are a lot of links there. There's not any self-quiz on that page. And you go through the whole book, okay? And starting here in application program, there's a self-quiz there. Acquiring software. Off-the-shelf software. There's a self-quiz. I think on all the rest of these are self-quizzes, okay? Excuse me. Operating systems. So you should do the self-quizzes, okay? It's a good way to prepare. Okay? These self-quizzes actually, click on that, okay? The device blank, okay, is software that's installed for each device connected to a PC that allows the OS to communicate with that device. It's a device what? Device driver, right? Operating systems are designed to work with specific types of computers and processors. True or false? The operating system plays a central role in the functioning of any computer system. See, some of these questions are, I really don't like their quizzes very well. I mean, if you can't, yeah, you can just guess the answers. Application software is written to operate on a particular type of computer, regardless of its type of operating system. And operating system, okay, is a set of computer programs that runs or controls the computer. Well, an operating system, right? So it only has 5 questions on it in the game. And then it gives you the answers again. So device driver, the correct answer was C. Operating system, designed to work, and that's true. Operating systems, true. Application software, false. Oh, it's a pretty easy quiz. I mean, their quiz is a little too easy, actually, to give many cases. But some of the questions are good, okay, and you should go through and do that, as a way of reviewing. So to study for the quiz, I would say this: do what I just said, okay. Go to your textbook, do the self quizzes, okay. Look over the PowerPoint presentations, okay, for software and internet, and then you can go look at those lectures. Listen to the lectures again if you wish, okay, or parts of the lectures that you think might be important. Because sometimes I cover something in the lecture, and I'll ask a question on the quiz. And so I would say those are the best things to do. If you have a little hard copy textbook instead of this, you should read those chapters in the book, and that'd be about it, I'd say. So, any question about the quiz? That'll be Thursday, and it won't take up the whole time. Okay. Okay. Now, your assignment 2 is due on Saturday. What is this coming Saturday? The 20th. Okay. You can't hand it in late, okay? We don't take late assignments. And so it has to be handed in by then, okay? Now, how are we going to grade this? Well, I talked met with the graders today, and what I said is, well, these people are going to give a little talk, a 5-minute talk on this. And so between making the PowerPoint presentation, giving the talk, is going to be 100 points, okay? So the presentation, the PowerPoint file, okay, it's this PowerPoint PPTX file that's due Saturday, okay? You turn it in using Blackboard turn-in facility, okay? Does anyone want to go through that again? You want to know how to turn it in on Blackboard? If you don't know how to turn it on Blackboard, come see me at the end of class. Yeah, so that's going to be, this is going to be 60 points for the file, and then 40 points for the presentation. Now, of course, you can't get that 40 points until you make the presentation. So I told the graders to split that uh, assignment into 2 columns. So we're going to have assignment 2, the written part, okay, it's going to be worth 60 points, and assignment 2, the verbal part, is going to be 40, but they're going to be 2 columns. Yeah. And the way we're going to do that is I'm going to call on people all the rest of the semester, about 3 people a day. And then I'm going to be out on November 20th. And so one of the graders is going to take the class, and we're going to have PowerPoint presentations all day. Yeah. Oh, when you actually make, and then from my computer here. Okay. You're going to stand right here. Because you can't control the computer. What? 5 minutes. So we stop at 5? Is that the minimum or is that the maximum? I want you to talk exactly 5 minutes. It's like 5 minutes. More or less around 5 minutes, yeah. I can make it like 15 minutes if you want. I know, yeah. That's what I'm afraid of. Okay, the PowerPoint file itself, we're going to look for that animation. I said you should do an animation, okay? And the animation is going to be worth 25 points. Then, I guess we're looking for a good style. And that's going to be 15 points again. We're going to see if the amount of text is proper. That is, you don't have a whole bunch of text that nobody can read, okay? So I guess sparsity of text. Right? City, how do you spell that? I don't know. Sparsity. Or it's, I don't know. Anyway, it's 15 points. Uh, Text, okay? No, well, not, well, say, not too much text. Okay? I can get an example. I don't know that I have an example. I read it. Yeah, yeah. If you just if you have a whole paragraph, okay, that's too much. Okay? Even a whole sentence, okay, is if it has a lot of stuff you don't need, it's too much. Okay. You want to boil it down, okay, and use as little text as possible. Okay. This is like another 15 points. Okay. 30. And there's another 15 points. Okay. And that is a good a mixture of multimedia. That is mixture of graphs. We want graphs, pictures, whatever. You may even put a little video in. Find one. That'll take 5 minutes. Okay. Multimedia. That's what we're looking for. Okay. Okay. Any questions about assignment 2? Yeah. No. Not a long one. Okay. Okay. All right. So today I want to talk about the internet. World's largest public computer network. Okay. So the internet is the world's largest what? Library. It's the world's largest casino, and it's the world's largest department store, grocery store. Right? What else is it? Yeah, the world's largest what? Yeah, movie. Yeah, world's largest movie theater. Movie house. What else? Pornography shop, right? What else? Well, so many of these things. Okay, I mean it's truly you know a marvelous thing, the internet. Okay, who would ever have guessed? You have all of this stuff at your fingertips. You know, the internet is so pervasive that often people don't go any further than the internet. And finding something out. You want to know something? You want a recipe? Okay. My wife often wants a recipe. She doesn't have a recipe for something. She get a recipe off the internet. Right? Say somebody quoted this quote came from somebody. Who was it that said this? Okay. A little bit of it. Okay. Tell you who it was. Okay. I mean, it's basically enormous. Well, how did the internet get started anyway? Anyone know? What's DARPA? That's Advanced Projects, Advanced Research Projects Administration. And so it's part of the Department of Defense. Okay, it's a research section of the Department of Defense. Now, actually, this DARPA used to just be called ARPA, and it was around 1969, I believe, when this ARPA created something called the ARPANET. And the idea in the ARPANET projects. So in 1969, they created this ARPANET. And the situation, was, and still is, they have all these research labs around the country. So up in Chicago, there is a research lab just outside of Chicago. In California, they have one in Livermore, okay. Lawrence Livermore, okay, research lab, okay. The one in Chicago is called Argonne National Lab. Lawrence Livermore Research Lab. Mm-hmm. And L.A. NL. Actually, I guess it's the actual name of it is LLNL. National Lab. They're all national labs again. Los Alamos National Lab. Oak Ridge National Lab. Brookhaven National Lab. A bunch of them, okay? And so these scientists work together and we're doing research of national interest. And so at all of these places, they had these big computers. And so the fact that these researchers at all these places were working together, many of them on the same projects, they thought to set up a network, okay, of all these computers. And so basically, they wanted a network where information could be passed back and forth between these laboratories. And they wanted this network to be duplex. That is, there's always two paths, okay, from each lab to each other lab. So in case one of the paths went down, there'd always be one left, okay. that was critical for national interest. So, and they had these telephone lines connecting all of them, and basically they're pretty much following the work done in the Multi project. And they had this all set up, and there were three applications they particularly wanted. Okay? They wanted to do email. That is, these researchers in all these labs could send email to one another. So it was the kind of the first email, basically. And then they wanted to be able to do file transfer. That is, files that were on one computer that I could be able to send to any other computer on the network. And then they'd also like to do remote login. That is, a researcher at Lawrence Livermore could log in to the computer, at Argonne. And so these were the three applications that drove this ARPANET originally. So this ARPANET was the beginning of the internet. And so the internet basically started with ARPANET. And these connections between these labs and the ARPANET sites were very, very fast. And so these connections between these national laboratories sort of became the main trunk, okay, of the internet. And so they would then connect basically universities. And research labs, other research labs. So this ARPANET started in 1969. I think the University of Houston first got on ARPANET right around 1980. Or at least the computer science department got on around 1980. The whole university got on around 1986. And so then this became known as the internet. In 1991, it was authorized for commercial, and the general public, okay, was given access to the internet. I think the first people that got on the internet that were not these research people, it started about 1993. By the end of 1993, 94, they left the .com zone. And with the allowing the opening of this internet in 1994, was the beginning of the internet that was known then to the general public. So there are many different internet technologies. Okay? So we have the internet backbone. Okay. Now originally the internet backbone was this ARPANET, but nowadays that's not the backbone any longer. The backbone is now, I guess that's part of it. Okay, but it's supplied by AT&T, all these different telephone companies. Again. So the internet backbone, okay, the main internet pathways, okay, connections, okay. So it's right, Verizon is part of it. Okay, AT&T, Sprint, okay, all of these, okay. So in the communications business, when you have a telephone line that connects two or more uh, places together, okay, there are different speed ratings. Okay, let's talk about the T1 line and the T2 line and the T3 line. Okay, the T1, was about 1 million, bits per second, and it went up from there. And now they talk about the OC levels. Okay, OC1, OC2. Okay, but today the backbone of the internet, extremely fast. Okay, and it varies. Okay, from place to place. Okay, so everything is protocols on the internet. So when one computer talks to another computer, it does so through a protocol. The main protocols on the internet are IP, that's the internet protocol, and TCP, okay, that's the transmission control protocol. Now, the way the internet works is like this. Let's say you've got a computer over here, computer one, and then you've got a computer somewhere else on the internet over here, C2. And let's suppose there's a person sitting at computer C1, and this person wants to send email to somebody who's, say, at computer 2. So this person sitting at C1 will draft this email document. They'll bring up their favorite email program, and they'll write all this stuff, right? Email messages can be little short ones, or they can be long ones. Okay? And after starting this message, this person at C1 will then hit a send button, and then they're sending this mail here, this little message, to the person at C2. Well, so you have here the internet, and we call it the cloud, right? And you might think that when you say send an email, to this person, that that whole message basically gets sent through some path, okay, of the internet. But that's not true. What happens is this message is divided up into little packets. Really quite small packets. Okay? And each packet is sent off separately. So this would be the first one, the second one. So it's divided up, and it depends on how long the email message is. Now, packet one finds its way somehow through the internet. It finally winds up at C2. Okay? Packet one, okay? Packet two here finds its way through the internet. and packet 3. Okay. And they all basically just go their own little separate way, except they all start at C1 and they end up at C2. So this is called a packet. So the internet is a packet switching network. Now, when they arrive at C2, it's not true that packet number 1 actually gets there first. They arrive in some order, not necessarily the order in which they were sent out. So the internet protocol, its job is to see that each packet gets there, and that the computer C1 ultimately knows that it got there. Okay. So IP basically guarantees the integrity, okay, of the message. TCP basically puts the packets back together. Okay. Well, it takes the packets. On the one end, it takes the packet, it creates the packets. Okay. On the other end, it puts the packets back together, so that the person over here actually gets the email message. Yes. IP. Everything that passes through the internet, is an IP packet, and it's to ensure that it gets there. Okay. The main objective is that each packet makes it. Yeah. TCP, what? TCP creates the packets. Okay. IP doesn't even know anything about the packets. I mean, they're just different. He doesn't know that IP doesn't know that these packets actually are part of a message. This is a packet. Okay. I don't care where it came from. Okay. It's a packet that has to go from here to here. Okay. And its job is to get it there. Okay. And see that it gets there. TCP breaks it down and puts it back together. This notion of a packet switching network was actually created by a professor at the University of Hawaii. Now, why do they do that? Why don't they just send the whole thing? The reason for making the internet a packet switching network is to utilize all of the parts, okay, of the internet equally. See, these packets are all pretty much the same length. And so, if you set this whole file, and some of the files that are sent through the internet, are millions and millions of characters long. You really don't want to send the entire thing on one route, okay? Because these millions and millions of characters all got on this one route, that particular part of the internet is tied up for some time, okay? So this packet switching basically, you know, yeah, IP find different paths, okay, for all these things. And so you get a better overall utilization of this network. So the protocols on which the internet are based are the TCP and IP. Internet applications divide up information, okay, such as an email message into small packets. Okay, you have internet service providers. Okay, that's the company that you pay money to every month to be able to use the internet. Okay? So a company that provides this is Internet ISP, and you know the ISP are companies like AT&T. They're like Comcast and others. Okay. So when you hook up to the internet, when you hook your computer up to the internet, you have to have some way of hooking it up. Okay. One way of hooking it up is a plug like this, which is an Ethernet plug. Okay. So I have an Ethernet plug here into this computer. Okay. So this was hooking this up to the internet, or nowadays, wireless connection. It's a radio, basically, a radio signal. This internet plug or Ethernet plug looks like a telephone plug, but it's not. It's wider. So if you try to put it into a telephone jack, it won't fit, and that's good. Okay, so another thing about the internet, the technology, is it uses something called uh, client server model, okay, or the client server architecture. So there are all these computers on the internet that are servers. So you just have some computer, and this computer can declare itself to be a server. It's just like a person opening up a shop, right? Just like a person goes to decide, I'm going to, open a grocery store. So they go, they rent a grocery store, put signs up, and open for business. Okay? And the server is just like that. It basically open for business. Okay? And the server has to run a server program. And the server program um, basically has to basically handle certain types of service. Okay. Now, I said originally the internet did email and did file transfer and did remote logon. Those were the three applications, that were done originally. Now, of course, it does a lot more. Okay, because it runs, among other things. I mean, originally the internet didn't have any World Wide Web on it. Uh, the World Wide Web came along soon enough, but now, of course, you send web pages. You can also send, buy things on the internet nowadays. Okay, so basically, you send various types of forms. It's sent over the internet. Okay? Various types of information. Now, there are servers. There are email servers. There are file transfer servers. There are basically remote logon servers. There are web servers. There are all kinds of servers available on the internet. Now, each server, okay, so now there's a server machine, okay, And the server machine runs a server program. And the server program, okay, is usually will handle, all these different protocols. Now, each one of these types of information is sent via its own protocol. So, for instance, we have FTP, the File Transmission Protocol. The File Transmission Protocol is an old protocol, and in fact, we're about to get rid of it, okay, because it's not a real safe protocol. These older protocols are the less safe, okay. As you may know, there's a lot of mischief that goes on the internet, and people write things called packets, okay. And since the internet works on packets, okay, these packet sniffers basically are watching, stuff go back and forth over the internet. They know they're packets, okay, and they know how packets work, and so they try to get enough packets in the same uh, file, and sometimes they're successful in doing that. This FTP protocol is replaced by a more modern protocol called the SCP protocol. And SCP stands for the Secure Copy Protocol. Remote logon, that was called the Telnet protocol. It's also being replaced by more secure. Web pages are, of course, HTTP protocol. So there are all these protocols. There's actually hundreds of internet protocols. So the client, and the client server model. So the server is sort of always up, okay? Open for business. And the server has to be configured to be able to handle a certain number of clients, okay? I mean, it's just like a store, okay? You got to configure the store. You got to have enough salespeople in the store to handle the clients, okay? And so the people who build a server have to worry about how many clients, they'll have all at the same time. And let's say the server is set up that it can handle 50 clients at the same time. So here you'll have a client, and the client contacts the server saying, I would like some service, okay? And the way the client contacts the server is it basically sends the server, the server has one or more URLs, okay? And a URL, okay, is a universal resource. Sorry, they don't call it universal anymore. They call it uniform nowadays. Uniform resource location. And you know those, it's like HTTP colon slash slash, you know, CS dot, sorry, www.cs.uh.edu. Huh? So this over here is the protocol. This is the computer that handles the web pages. Okay, it's a web server. Okay. And then these are directories, okay, inside the web server. So the client then contacts the server, and the server, let's say, each different protocol has a port and a port number. Okay? So HTTP has a port number, okay, and Telnet has a port number, okay, and so forth. And so the client, the server will be able to handle 50 people on this port, okay, and the server then will respond back to the client, okay, and acknowledge, okay, and set up a session, okay, and then the server will send the client the home page, okay, that he asked for. So the client makes a service request, okay, and the server provides the service again. Peer-to-peer networks don't use the central server. So I'm getting up to router, okay, and I'm running out of time, okay. And we're going to look next time at router. But this is as far as I'm going to go. The quiz, okay. I'm not going to ask about a router and quiz or anything else in this chapter, okay. But I will ask about the history of the internet. We'll talk about maybe ask a question about TCP/IP, internet service providers, okay, client server, but not the rest of this stuff. Okay. Okay. Any last minute questions? All right. Thank you very much. Mm-hmm.